Hello everyone. For my machine learning project, I selected the problem of predicting IT support tickets that are likely to breach their service level agreement, or in short terms SLA. In large organizations, support teams handle hundreds or even hundreds of thousands of tickets each month. Some tickets fail to meet their committed resolution timelines due to factors such as complexity, workload, reassignment delays, or resource constraints. Today, as support managers often really rely only on manual monitoring and their experience to identify tickets that are at risk. This approach is reactive and may not always detect issues early enough. I believe this is a strong machine learning opportunity based on the three evaluation criteria discussed in Module 1. First, it involves repetitive decision making because support teams continuously assess which tickets need urgent attention. Second, historical data is available. Ticketing systems already store information such as priority, category, assignment group, escalation history, resolution time, and status. Third, solving this problem has clear business value. By predicting high risk tickets early, organizations can reduce SLA breaches, improve customer satisfaction, increase efficiency, and optimize resource allocation. Based on these three criteria, I believe this is an attractive machine learning use case. Now, so coming to CRISP-DM business understanding, right? So next I applied this CRISP-DM business understanding framework. The first step is to determining the business objective. The primary objective of this project is to reduce the number of support tickets that breach their SLA commitments. The secondary objective is improving customer satisfaction by ensuring faster and more consistent resolution of issues. The second step is assessing the current situation. Currently, support teams rely heavily on manual prioritization and experience based decision making. While this works in some cases, it becomes increasingly difficult when tickets volume rise. As a result, organizations often react to problems after have already begun. The key stakeholders include support engineers, support managers, IT operations leadership, and end users who depend on timely support services. The third step is determining the machine learning goal. The machine learning goal is to build a classification model that predicts whether a ticket is likely to breach its SLA at the time it is created. Finally, the high level project plan includes collecting historical data, preparing and analyzing the data, developing the model, validating the results, conducting a pilot development, and monitoring performance after deployment. Now, coming to our next slide. After defining these business objectives, the next step is defining success and defining relevant factors. The expected business impact of this solution is improved SLA compliance, reduced ticket escalations, better resource planning, and improved customer satisfaction. For this project, I would expect the solution to contribute to a meaningful reduction in SLA breaches while helping support teams focus their effort on the most critical tickets primarily. To evaluate business outcomes, I would track outcome metrics such as SLA, complaints rate, mean time to resolution, customer satisfaction scores. In addition to business metrics, I would put some output metrics that measure the model's effectiveness. These include precision, uh, recall F1 score, ROC, AUC. These metrics help determine how accurately the model identifies tickets and are likely to breach their SLA. Also identified several potential factors that could influence the prediction. Uh, these include ticket priority, category assignment, team workload, escalation history, resolution trends, and information contained within the ticket description itself. These factors would serve as model inputs during training and prediction. Moving on to next slide. The proposed solution is a supervised machine learning classification model that predicts the probability of an SLA breach. When a new ticket is created, a model analyzes its characteristics and generates a risk score indicating the likelihood of missing the SLA target. Before implementing the solution broadly, I would execute a series of validation experiments. First, I would conduct interviews with support engineers and support engineers to validate the SLA breaches are a significant problem and to understand how they currently prioritize tickets. Secondly, I would create a prototype dashboard showing ticket risk predictions and gather feedback from potential users regarding usability and usefulness. Third, I would validate the machine learning model using historical data and compare predicted outcomes against actual outcomes. Finally, I would conduct a prior pilot rollout with a single support team and measure whether predictions help improve SLA performance, and then before expanding to additional teams. I also consider three key machine learning system design decisions. The first decision is real-time versus batch prediction. I selected real-time prediction because support teams need immediate visibility into risk as soon as a ticket is created. Second decision is human in the loop versus full automation. I selected human in the loop because model should support decision making rather than automatically altering ticket priorities. Human oversight helps ensure accountability and trust. Third, the decision is cloud versus edge deployment. I selected cloud deployment because ticketing systems and historical data are typically stored in cloud-based enterprise environments, making deployment and maintenance clear. Finally, it is important to consider risks that may arise when a model is deployed in production. One potential issue is data drift over time. New over time, new product services or ticket categories may be introduced, changing the characteristics of incoming tickets. Another risk is concept drifts. Business processes and support workflows may evolve, causing relationships learned during training to become less relevant over time. Training serving skew is also a concern. The data available during model training may differ from the information available when a prediction is generated in production, leading to reduced accuracy. Latency can also affect adoption. If users do not receive predictions quickly enough, they may stop using the solution. Finally, bias may emerge if historical ticket handling systems contain inefficiencies or inconsistencies that are learned by the model. To mitigate these risks, the solution should include continuous monitoring, periodic retraining, and then strong data controls and regular performance reviews. In conclusion, this project demonstrates how machine learning can be used to proactively identify support tickets that are likely to breach their SLA commitments by, by enabling early intervention. A solution has the potential to improve operational efficiency, enhance customer satisfaction, and reduce service delivery risks. Thank you for listening to my idea.